So we're going to go through the three painful ways to find area under a curve that they used to do. And then they found out that we could do integrals or antiderivatives and it would find the area under the curve accurately instead of using 977 rectangles. Right? Fun. Cool. Awesome. Great. So we have y equals x squared. We're going to use the basic one. Okay? Today's a big lesson day because what I want to do for Friday is I want to just review for the test on Monday. So we have to do a double lesson day. All right. So we're going to find the area under the curve between 0 and 4. So if we sketch this out, I'm going to be nicer. I'm going to do 0 and 2. Okay. So we have 0, 0. We have 1, 1. We have 4, 2. 2, 4. Don't know what I'm saying. Okay. Shh. Quiet, please. Seth, that's you. Shh. So, we have a curve. Here it is. And we're trying to find the area under it. This part. Correct? Area under the curve. So, what they taught us is they thought, well, hey, could I just put a whole bunch of rectangles under there? And then if I put rectangles under it, I could kind of figure out the area even if there's a curve. So, we're going to do it with 4 rectangles. Called 4 sub-intervals. Is how they'll write it. So we need to split this. So we're going to have 0, 0, and then we need to have this coordinate as well, and this coordinate as well, the one in the middle, right? So we need at 0.5, and then we need at 1.5. Should have done before. Possibly been easier, but the graph would have been harder. So this one is going to be 0.5 and 0.25, right? So we have 0, 0 to help ourselves out. We have 0.5 and 0.25. Then we have 1, 1. And then we have 1.5 and 2.25. And then we have 2 and 4. Just writing the coordinates here so they're out of the way. Just to remember what they are. So, what they said is, we could split this into 4 subintervals. So, you could do left-sided, right-sided, or midpoint. So, we'll do left-sided first. Left-sided means left-sided heights. So, I'm going to do left-sided in blue. So we're going to split this into 4 rectangles where these dots are, correct? But we need to use the left side of it. So the left side of my height is going to be height of 0, and then the width is what? 0.5, right? So that's my first rectangle. It's literally a flat rectangle. And my next rectangle, so it's underestimating what the actual area is under the curve, correct? Then we do the next one for the left bound, so I go up to the left coordinate, follow it over, follow it down. That's my second area. Still underestimating the area, correct? Then my next left one, I go up to this side, follow it over to the middle, follow it down. That's my third rectangle. And then follow it up, follow it over. So am I going to get a proper area here? No, I'm going to have an underestimation, correct? So instead of having 4 rectangles, what could be a better way to go about it? Tech right. Tech deck. 10 rectangles. If I did 10 rectangles, it would get closer and closer and closer to having less of this area open, correct? or if I did 100, or if I did 1,000, or if I did 1,000,000, right? I would get lesser and lesser of that underestimation, right? But for now, we have 4. We are welcome. Okay, so left-sided, we have to have area. So it's going to be area of rectangle 1 plus area of rectangle 2 plus area of rectangle 3 plus area of rectangle 4. You need to be able to do left-sided, right-sided, and midpoint because they will ask specifically for those. So if you're like, but I wanted to find the actual area, too bad, so sad. If they ask you for left-sided, 4 subintervals, you have to do that. Okay? So each of these is a rectangle. Each of these has a width of what? 0.5. Now, they say change in x if you want to figure it out. You do b minus a divided by n. B is this. A is this. N is that. Okay? So it would be 2 minus 0 divided by 4, which is 0.5. This one, subinterval, was easy to figure out, just to pick something nice, right? But that change in x is going to be your width. So the width of each rectangle is not changing. We agree? Now on AP questions, sometimes they'll give you different widths and different heights, and you have figured out on a t-table. But for this, we're keeping it this way. And we'll practice those before the AP exam. All right. So what's the height of the first rectangle? Or the length? No, that's your question. It is 0. And what is the width? 0.5. So we're going to get 0 times 0.5. That's area 1. Plus, what's area 2? What's my height? .25. It's right down here. 0.25. And what's my width? 0.5. Area 3. What's my height? 1. And what's my width? 0.5. Area 4. What's my height? 2.25 and 0.5. Why am I not using 4 in this? Pardon? The rectangle doesn't go there. That would be a right-sided rectangle, right? Correct, I mean? So the faster way to write these, if you wanted to, what could I take out of all of these? 0.5. So I could technically go 0.5, 0 plus 0.25 plus 1 plus 2.25. If I wanted to, correct? Because each of them has the same change in x, same width. Could I have just done the math though too? Yes. So here this would be 0.5 of 3.5. What's half of 3.5? 1.75. So that would be my units there. Oh, cupcake. You late to the date.
I think you guys just...
No. You might want to borrow a chair. No. Go borrow a chair. That was my hint. I'll say no. Not today. All right. So we underestimated the area, correct? So that area is for sure bigger than 1.75. Okay. Then we're going to do right-sided. Like I said to you, do you get to choose? If they say right-sided, do you get to be like, nah, I don't want to do that? No. So we still are going to have 4 rectangles, correct? Because it's still 4 subintervals. But what's changing this time? What of the rectangles is changing this time? Did the width change? No, the width is still 0.5. That's not changing. If I take the right-sided, what's changing? The height. So now I'm going to the right side of this. This is my rectangle, right? This right here, that's my rectangle. That's the bottom of it. Well, this is going to go up to the right side now and over. So what's this going to do now? Overestimate, correct? This is going to go over to the right side, over and down. It's going to go to the right side, over and down. It's going to go to the right side, over and down. So what some people write to help them out for right-sided, so I have the numbers 0, and then 0.5, and then 1, and then 1.5, and then 2, correct? The right-sided ones are these ones, are they not? So what they'll sometimes do to show you the area, for area 1, they'll say the width, which is 0.5, times f of 0.5. That's the right-sided one, correct? F of 0.5 is this height, yes? And then they'll go plus 0.5 times f of 1, plus 0.5 times f of 1.5, and then plus 0.5 times f of 2. These ones, this was f of 0, f of 0.5, f of 1, and f of 1.5. Because it was the left-handed sides, right? Do you get what I'm saying? Now we're doing the right-handed ones, which is this one, this one, this one, and this one. The left sides would be that one, that one, that one, and that one. Kind of make sense? A little bit? So, our area is going to equal 0.5, and then f of 0.5, if I plug in 0.5, I get 0.25, plus 0.5 times 1, plus 0.5 times 2.25, plus 0.5 times 4. Now you can take half of all of those and then add it up, which is harder if you don't have a calculator in the non-calculator section, right? So what I prefer to do is pull the 0.5 out and then add up the rest. So I get 2.25, or 2.25, 2.5, 6.5, 7.5. I have half of 7.5. What is half of 7.5? So for me, I find it easier if I just add them up and then take half of it, than taking half of all these blue decimals. Because you get 1.25. 0.25. Units squared. So this one did what? This area. Overestimated it. So now we have an area that's under it, and we have an area that's over it. Cool. Can't go under it. Can't go over it. Must go through it. So we're going to midpoint. So midpoint I'm going to draw separately just so that we can, actually, because midpoint gets a little more dicey. So we have 0, 0.5, 1, 1.5, and 2. So what's our width still? Our width is still 0.5, right? That didn't change. But now we're going to do midpoints. So back here we did 0.5 times f of 0 to the left times f of 0.5, 1, and 1.5. Here we did f of 0.5, f of 1, f of 1.5, f of 2. Now we're doing midpoints. So the width is still 0.5, correct? But the height is actually directly in the middle. So if I followed it up, it would be like this now, which is a better estimation, correct? Because you have a little bit above and a little bit below. So this would be at 0.25. We agree? Then this one here is at what? 0.75. So I follow it up to the line, and I follow it over to here, down, follow it over to this line, and down. So a little bit above, a little bit below, correct? And then this one here would be at what? 1.25. Follow it up. And I follow it over till I make my rectangle, follow it over till I make my rectangle. So this would be area 1, this would be area 2, this would be area 3, and then this one is 1.75. And I follow it up to the middle, follow it over, down, down. That would be area 4. So I still have 4 areas, just like I did for the other ones, correct? These ones are a little more accurate because you have some overestimation, some underestimation, so they should kind of like find the mean, the middle of it, right? So when I go to set up my formula, my area 1 is going to be 0.5, which is the width, times f of 0.25. Then area 2 is 0.5 times f of 0.75. Then plus 0.5 times f of 1.25. And plus 0.5 times f of 1.75. Easy to find f of those numbers because the original equation is just x squared, right? So we're going to get area equals 0.5 and then 0.25 squared is 0.0625 plus 0.5. And then f of 0.75 is 0.75 squared when you fill it into the formula. And it's 0.5625. Zero 0.5, 1.25 squared is 1.5625. Zero 0.5 times 3.0625. I get 2.625, which falls in the middle, right? Okay, I'm going to show you how to find the actual area with your calculator, just to see where it's at. We have to find it algebraically as well. But can everyone go to their y equals and type in x squared? Because this is the way that works for everyone, and then I'll show you the way that works with the fancy calculator. So you're going to go, once it's in your y equals, go zoom 6 so you can see it. So do you see your lovely little x squared graph from zoom 6? Okay, you're going to go second calc, or trace, and we're going to pick number 7. dy over dx is something we're going to talk about when we go to practice questions. That's the derivative one. Okay, so it says lower limit. What's our lower limit? 0. Enter. Then it says upper limit. What's our upper limit? 2. Enter. What's the actual area? 2.666666666 repeating. Correct? So it's pretty close, but it's not completely accurate. Right? Now, if you have the fancy calculators, I'm going to show you how you can do this. So when you're finding the area, technically correctly, which we're going to do at the end of today, you would do from 0 to 2 in an integral x squared dx. That's how we write it out. The area would be from 0 to 2 x squared dx. Okay? If you have the fancy calculators, you can do it this way. If you have TI-83s, do it the other way. You can go math and then arrow up to number 9, or just press number 9. And we'll go 0 to 2 of x squared dx. Same answer. The great thing about putting it into your y equals is it'll literally shade it underneath, so you'll see that it's shading under the curve. But you do nothing because you don't have it. Just the x squared. And then you go second trace, number 7, lower bound is 0. So you go, then you just press 0, enter. Because you moved it. So it was kind of close. We agree? The other two were way out to lunch. But just because you think they're out to lunch doesn't mean you get to just not do them. Sorry, sucks to you. Okay. So I'm going to get you guys to do this one. So f of x equals 16 minus x squared on 0 to 4, the domain 0 to 4. And I want it in, we'll do 4 subintervals. It was 4 or 8, but that'll be nice. 4 subintervals. Now, you don't have to sketch the graph to do these, just so you know, but I will always sketch myself a number line. So watch, this is what I do. So I will go 0 to 4. If I want to know the break of my work, I would go change in x, or the width, right, equals b minus a. So it would be 4 minus 0 divided by 4. So this one's nice, it's 1, because I picked a nice one for you. Okay? So we have to split this up. 0, 1, 2, 3, 4, correct? Now the catch is figuring out which are the numbers you use for right and which are the numbers you use for left. So if I went to do left, my width would still be 1. That doesn't change. But what would I use for left? 0, 1, 2, and 3. That would be my lefts, right? F of 0, F of 1, F of 2, F of 3. Because those are the ones on the left. Correct? And I would get 4 rectangles that way. What would I use for right? F of 1, F of 2, F of 3, F of 4. Correct? What would I use for midpoint? What would I use for midpoint? For midpoint, because you're probably somehow involved, 0.5, 1.5, 2.5, 3.5. But we would use f of those, correct? So we'd have to find out what they are as the y values. We agree? Does that make sense? So left bounds would be F0, F1, F2, F3, and you have to plug them into here. Right bounds would be 1, 2, 3, 4, and then midpoints would be the midpoint. But you have to plug them into here to get what the y value is, correct? So like, actually I'm going to let you go. Try them out. What is the minimum you need to show? So what you can do is, for right, do you want to do right or left? Left. So left side are the ones on the left, right? So left sided. So at minimum, what I need to see is the width change. So 1, you could take it completely out or you can put it with your area. 1 and then f of 0 plus 1 times f of 1 plus 1 times f of 2 plus, I don't know why I'm doing extra brackets, 1 times f of 3. Now, if it's a calculator section, you can find f of whatever using your calculator, correct? If it's a non-calculator section, you're going to have to algebraically do it on a piece of paper because that's how it works. The decimal ones would be kind of ugly. But they'll have to give it to you in a table of values. If they ask for it in a non-calculator, they'll give you like the table of values. This is what x is, this is what y is for this function. Okay? So let's type the original into our calculator. So we go 16 minus x squared, right? So I can do it quickly in the fact that once I have that, I can just go second trace value, correct? And I can go 0. Oh, it's 16. So I do 1 times 16 plus 1 times, oh, I need 1. 1, enter, 15. Plus 1, 2, enter, 12. Plus 1, 3, enter, 7. So I'm still showing what I'm finding. I'm just using my calculator to get that answer. And that's fine. Okay? The reason why the AP exam sometimes goes terribly is you guys are so used to us drilling that you have to show everything algebraically that you're like off to the side finding these out, showing f of 1, f of 0, f of... You don't need to do that. If you show this, and you show that f of x is that, then you've shown the values, right? So then we get 16 plus 15 plus 12 plus 7, and we get 50 units squared, because it's area. Okay, then we'll do right-sided. Can I go right to going 1 outside of it, being the width, and go F1, 2, 3, 4? Can I take that GCF of the width out right away? You can only take the width out if it's the same. Sometimes they'll give you a table of values, and the difference between the first 2 values is 1, and then the difference between the next 2 is 2, and the difference between the next one is 1, and the next difference in the next one is 3. Then you have to do each area separately, right? Because your widths are all going to be different. Sometimes they give you a table that way. All right, on the AP exam. So here we're going to go area equals 1, and then we get 15 plus 12 plus 7 plus 0. So area equals 2750. Wow. 2734 units squared. Yeah? Okay, then we do midpoint. Okay. So midpoint, we now need area equals, we can leave the 1 outside because they're all the same. And now I would get f of 0.5 plus f of 1.5 plus f of 2.5 plus f of 3.5. So area equals, second trace value 0.5, 15.75 plus 13.75, then 2.5, 9.75, 3.5 is 3.75. 43. Can we find the actual one now? Use your calculator. You're going to go between 0 and what? 4. Let's go. Do it however you want. Second, I have it in my equals already, so I'm going to go there. Second trace 7. 0, enter, 4, enter. Everyone calculate it properly. What does the area give us? 42.66666, and this was 43. So pretty close, but not accurate, right? So if they ask you for right bounds and left bounds or midpoints and you give the true answer, they're going to know you didn't do what they asked because they don't match, right? And you might be like, but why wouldn't we just do the correct answer? Just so you know, when your calculator is doing the area under the curve for you, this actual answer, the integral, what it's doing is it's making the number of rectangles infinite. Because if I make 100 rectangles, the area will be closer, correct? 1,000 rectangles will be closer. 1,000,000 rectangles will be closer. But the best way to do it is to have an infinite number of rectangles. Then it'll be perfectly accurate. It'll be like this, right? Going along. Okay? Does this make sense? The left, the right, and the midpoint? It's not bad. Some people are lost souls on it. So are any of you lost souls? Or does it make sense? Do you have to draw the graph? No. Can you just draw the number line? Yes. You can. Okay. So we're going to do true area. 0 to... 8's going to be giant. I'll do 0 to 2. And then I'll do... No, I'll do 0 to 3 because I want to change it up. 0 to 3, 6 subintervals. So when we talked about finding the area under a curve, and I showed you on the fancy calculators how you could do it, you could go like 0 to 2 x squared dx so that it would get you the answer. Well, how the heck does that do it algebraically? So the fundamental theorem of calculus follows this formula, which once you do it a couple times, you are going to need a formula. It's from a to b f of x dx. So if I'm trying to find the area under the curve, say f of x is any function from an a value to b, lower limit to an upper limit. The way that I do that is when I go back to capital F is the antiderivative. So I'm going to do the antiderivative of f and fill in b minus the antiderivative of f and fill in a. And it'll give me the answer that our calculators have been giving us. Okay? So we're going to pull the example from what we did before. So I think mine's still on the calculator. X squared, 16 minus x squared? Yeah. So y equals 16 minus x squared on 0 to 4. Right? That was the last example we did. So how we represent that is using an integral. Now we're going to do just integrals all day today, but I want to prove to you that area, the reason why we're learning the fundamental counting principle is to learn to find the area under the curve without having to do left bound, right bound, midpoints would be kind of close. Okay? So how we would set it up is we would go area equals 0 to 4. We're not going to do areas today. We're just going to show that this one works with area. Other than that, I'm just going to give you integrals and you're going to solve them. Okay, this symbol's an integral symbol. It's a symbol that's on the outside of the white textbooks that everyone else uses. We put the actual function here, and then we follow behind with the variable, dx. Now, if this function was like 16 minus g squared, then I would have a dg, right? It's just whatever the heck the variable is. You guys like x's more. It's just born into your souls, the thing. Now, dx just means I took the derivative of this. Okay, so this is actually the derivative, 16 minus x squared. I want to be able to get the antiderivative so I can plug in f of b minus f of a. So I'm going to show you the interim step. So we do the antiderivative of that. What's the antiderivative of 16? 16x. We did these yesterday. And what's the antiderivative of x squared? We're going to get minus x to the 3, and then we're going to divide by 3, which makes us have a 1/3 in front. And then how we show that we took the antiderivative of this, but we still haven't plugged in the 0, 4, correct? So how we hold that value so we know what it is we put a little boxy box back here like this, and we put 0, 4. If we kept the integral symbol, we would say that we have to take the antiderivative of it, right? But we did take the antiderivative, but we still have to show that we're going to put 0, 4 in. So we do this interim step where we put 0, 4 behind. And then the fundamental theorem of calculus says if I take f of 4, so if I take the antiderivative and plug in a 4, and I subtract, take the antiderivative and plug in a 0, I'll get the answer. So let's try it out. That's what this is, because capital F means antiderivative, right? So we're going to get 16 times 4 minus 1/3 4 cubed minus 16 times 0 minus 1/3 0 cubed. This one's awesome because the area is nothing. So what you're indirectly doing when you're doing this is you're finding the area of the entire curve at 4, and then you're finding the entire curve from 0 to the left. And so if I take, this is my curve. Let's pretend that's actually symmetrical. That sucks. I'm going to try it. Sucky. All right. So it's like that. I don't even know why I curved it the other way. But anyways, it's like that. That's 16. So this, filling in the 4, gets me the area from 4 this way, correct? 0, this one, can get me this to here. And then I just subtract them, and then I get only this area here. And I just use the same color, so that's not confusing at all. 2 different areas. You're welcome. All right. So, doing that math, 16 times 4 minus 1/3 of 4 cubed. I get 42.666. That's a thick marker. 42.6 repeating, or math enter 128/3. Now I have that sitting in my calculator. Second trace 7, 0 enter 4 enter, 42.66. Oh my goodness, it's the same answer. Oh. Yeah.
So then do we not include the C?
Stunner of me, not stunner of you. Good job. We're going to add the C, it just goes away. Because we're going to add a C and then we're going to subtract the C. So they'll just cancel off. So you should show it. Good job, Jayla. So the C's should be shown, but the C's go away. All right? Okay. So that's if you're finding area under a curve. So every single time you're actually doing the integral of any function, you're finding the area under that curve from low bound to up bound. Okay? So all we're going to do now, example 2, is we're going to use the fundamental theorem of calculus to solve the integrals that I'm giving you. So A is the first one. So it is from -2 to 1 x squared dx. So whenever you're given this, you're going to have to use the fundamental theorem of calculus to figure it out, which means we have to find the antiderivative of that from -2 to 1, right? So we'll do this one together. What's the antiderivative of x squared? X to the 3, and then I divide by 3, so I get a third. X plus c. The c should be shown here. And then we get -2 to 1. Right? And that shows that we're holding that -2 and that -1 in that spot. The plus c should be shown. And then we do upper minus lower. So we're going to get 1/3 1 cubed plus c minus 1/3 -2 cubed plus c. Now, what if you just type it into your calculator and it says algebraically? You get nothing. Right? But can we check always with our calculator? Yeah. You should be able to walk away from these being happy or sad. No in between. If you have the fancy calculators, you can literally type it in just like that. Remember under math? Pardon? So we're going to get the c's canceling off. Here we're going to get 1/3 up. Negative 8 times 1/3 is 8/3. So plus 8/3, which equals 9/3, which equals 3. Then let's try it out. So you can either put into your y equals, or if you use the fancy calculators, you can go math number 9. Math number 9, you can type it in just how it is. Negative 2, 1, x squared, dx. What did we get an answer of? 3. So we feel confident or sad. There should be no in between, right? Okay. Here's B and C for you. We're going to have a cos, and then we're going to have, well, let's see. Okay. So, B. We have from 0 to pi over 6. Remember, we're always in radians. Cos x dx. Remember, you're doing the antiderivative, not the derivative. B, and then C is 1 to 2, 1 over x dx. Let's see if you remember what the heck that the antiderivative of 1 over x is. So, what's the antiderivative of cos? We've talked about this. It was sine x plus c. And if you know you're right, you do derivative of sine x as cos. Okay, cool. Remember, you can double check your antiderivatives. So, we're going to do upper bound minus lower. So, sine of pi over 6 plus c minus sine of 0 plus c. Sine of pi over 6 is 30, which is a half. Remember, if you don't remember your unit circle, you can visualize it. So let's think about this. We have even just a piece like this. If this is pi over 6, correct? Say that's pi over 6. Remember that it's either a half or 0.8660, right? The root 3 over 2. If I actually look at this coordinate, it looks like my x is the 0.8661, correct? Because it's really close to 1. Remember, this is a 1. This is 0.866 approximately. So my x would be root 3 over 2. And then my y would be approximately what? A half, correct? And sine is y. So you can visualize them too if you just draw that quarter section. Okay. So it's a half minus 0. The c's cancel, so my answer is a half, if it wants to draw it. Okay, did anyone recognize what the antiderivative of 1 over x is? Ln x. Remember, if you don't remember, you could, some people will go like this, x to the negative 1 dx, and then they go to do the power rule, and you get 0 divided by 0, and be like, girl, she talked about this. She said we divide by 0, we cannot do that. There is a catch. What is the catch? Ln x. Yeah, okay, good talk. All right, so we're going to get ln of absolute value of x, because you can't have a negative beside our x, plus c, 1 to 2, and we get ln of 2, what am I doing, minus ln of 1. What is ln of 1? It's 0. Why is it 0? Let's talk about this, 30-1. Ln is log base e of 1, correct? Remember we talked about this when our calculator was doing this? Say we had 2 and 8. What did your calculator do to do this? It would say 2 to the power of what is 8? And you guys would tell me is 3, correct? So e to the power of what is 1? 0, right? So ln of 1, log of 1, anything like that, that turns to be 0. So my answer is ln absolute value of 2 minus 1, which is ln of 2. Done. Okay? That is a 0. I have no idea what you're talking about. My pen didn't keep going. Oh my goodness, there it is. I don't know what I was doing. Really flat, vertical, 0 looking 1-ish thing. Totally not though. Okay, so your homework.